Welcome to Two Projects. In this video, we are going to explain the project, a novel machine learning approach for Android malware detection based on the coexistence of features. Introduction. Android malware are harmful apps that pretend to be legitimate. This project focuses on static features like permissions, API calls, and code structure. Instead of waiting for malware to run, it spots threats by looking at these features upfront, offering proactive protection for Android devices. As the smartphone market continues to expand, the risk of Android malware threats also grows. Detecting and mitigating these threats is of utmost importance to safeguard user devices and sensitive data. Traditional methods such as signature-based detection have limitations. They can be easily bypassed by sophisticated, unclear techniques or by previously unknown malware streams. This project addresses these shortcomings. To tackle the issue of Android malware, machine learning algorithms are employed. These algorithms are trained to distinguish between legitimate Android applications and those with malicious intent. The project's unique focus is on extracting meaningful information from the co-occurrence of permission requests and API calls within these apps to enhance detection accuracy. And the outcomes of this project extend to various groups. Firstly, Android users stand to benefit significantly as improved security measures provide better protection against malware infections, ensuring a safer and more secure experience. Secondly, researchers in the field of cybersecurity gain access to a novel approach to malware detection, offering opportunities for further study and refinement. Lastly, cybersecurity professionals can enhance their toolset with an additional means of identifying and mitigating Android malware threats, reinforcing their overall defense strategies. Objective of the project. So, as I mentioned earlier, the core objective of this project is to create a highly effective Android malware detection system. The project is focused on harnessing the potential of machine learning. It aims to leverage machine learning algorithms to significantly improve the accuracy of Android malware detection. The project intends to explore and make use of three distinct malware feature datasets, Drebin, Malgenome, and CIC Malware 2020. These datasets will serve as the foundation for training and evaluating machine learning models. As an extension of the project, there is a goal to enhance the accuracy of the models. This will be achieved by implementing ensemble methods. These methods will further elevate the performance of Android malware detection. Another key aim is to develop a user-friendly frontend. This frontend will be created using the Flask framework and integrating with SQLite for user authentication. It will empower users to input data for malware prediction, making the system accessible and practical. Requirements needed to execute this project are hardware requirements, operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements needed are Anaconda 3 and Visual Studio Community version. So now we'll discuss the flow of work. The first step is importing required packages. In this step, we will import essential libraries such as NumPy and Pandas for data manipulation and analysis, sklearn for machine learning and data preprocessing, Matplotlib and Seaborn for data visualization. The second step is exploring the data set. The project involves the exploration of various datasets including Drebin, Malgenome, and CIC Malware 2020. This exploration phase includes tasks like loading the data, understanding its structure, and conducting initial data analysis to gain insights into the dataset's characteristics. So, Drebin is a well-known dataset in the field of Android malware research. It contains a large collection of Android applications including both benign and malicious apps. It is widely used as a benchmark dataset for Android malware detection due to its size and diversity, making it suitable for building robust models. Whereas Malgenome contains Android applications specifically focusing on malware samples. It includes a variety of Android malware instances. It complements Drebin by offering a specialized set of Android malware samples for research and model development. And CIC Malware 2020 is provided by the Canadian Institute for Cybersecurity and is known for its size, recency, diversity, and comprehensiveness. The next step is data processing. After data exploration, the project proceeds to data processing. This step involves tasks such as cleaning the data, that is, handling missing values, outliers, transforming it into a suitable format, and preparing it for further analysis and model building. The next step is visualization using Seaborn and Matplotlib. In this step, we employ Seaborn and Matplotlib to create visual charts and graphs, facilitating a better understanding of dataset characteristics. The next step is label encoding using label encoder. In this step, we employ a label encoder to convert categorical labels into numerical values, enabling machine learning models to work with them effectively. The next step is feature selection. In this step, we choose the X, that is features, and Y, that is target data. This involves identifying the relevant attributes that will be used to predict the target variable, which in this context typically indicates whether an Android app is benign or malicious. The selection of appropriate features is crucial for building an effective machine learning model for malware detection. The next step is train and test split. In this step, we segregate the dataset into training and testing subsets. The training subset is used for model learning, while the testing subset evaluates the model's performance on new data. The next step is training and building the model. So the project is focused on building machine learning models for Android malware detection using different datasets, that is Debian, Malgenome, CIC Malware 2020, and various combinations of features, that is API permission and combination of API and permission. So for each dataset and feature combination, several machine learning algorithms are applied to train and evaluate the models. So the algorithms include logistic regression. So logistic regression is a classification algorithm that predicts the probability of an input belonging to a specific category. It is often used for binary classification tasks where the output is either 0 or 1. It models the relationship between input variables and the probability of a particular outcome using the logistic function. It is employed in this project due to its simplicity and effectiveness in binary classification tasks. It is used to classify Android apps as either benign or malware based on the extracted features. The next algorithm built is support vector machine. SVM is a powerful classification algorithm that aims to find a hyperplane in the input space that best separates different classes. It is widely used for both binary and multi-class classification tasks. It maximizes the margin between classes, making it robust and effective in high-dimensional spaces. It is chosen for its ability to handle complex data and create clear decision boundaries. It is well suited for distinguishing between benign and malicious Android apps, which can have intricate feature relationships. The next algorithm is KNN, that is K nearest neighbor. KNN is a versatile algorithm used for classification and regression tasks. It assigns an input data point to a class based on the majority class among its K nearest neighbors. It is simple to understand and implement, making it a popular choice for various applications. It is utilized because it is a non-parametric algorithm that can adapt to various data distributions. It helps in identifying patterns in the dataset, aiding in the classification of Android applications. The next algorithm used is random forest. Random forest is an ensemble learning method that combines multiple decision trees to improve classification and regression accuracy. It creates a forest of decision trees and aggregates their predictions through voting or averaging. Random forest is known for its robustness and ability to handle complex data. It is valuable in this project to improve the robustness of malware detection models and reduce overfitting. The next model used is decision tree. Decision trees are versatile algorithms used for both classification and regression problems. They create a tree-like structure to make decisions by splitting data based on the most informative attributes. Decision trees are easy to interpret and visualize, making them useful for understanding the decision-making process in machine learning models. They provide insights into feature importance and can help understand the criteria used for classifying Android apps as malware or benign. And in the next step, that is extension phase, a hybrid model was created by combining predictions from multiple models for improved accuracy. Additionally, a user-friendly Flask-based front-end with authentication was developed. So we will utilize the extracted and preprocessed data to train the mentioned machine learning models. These models will learn data patterns and relationships within the data. After the training phase, we will assess their performance on a separate test dataset using metrics like accuracy, precision, recall, and F-score to determine their suitability for real-world applications. The next step is Flask framework with SQLite for sign up and sign in. In this step, we integrate user registration and login functionalities into the Flask framework. Users can sign up by providing their information and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. So after signing in, users provide input through the front-end interface. The input data are pre-processed to prepare them for prediction by the trained models. This pre-processing step ensures that user-provided data are in a suitable format for the model. The pre-processed user input is fed into the trained models for prediction. The best performing model is selected to make predictions based on the input data. And the predicted outcome is displayed through the front-end interface, allowing the user to view the results of the model's predictions or analysis. Now we'll look at the comparison graphs of algorithms built using Rebin dataset. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy score and on y-axis I have algorithm names. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. And this is precision comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is F-score comparison graph. In this graph on x-axis I have F-scores and on y-axis I have algorithm names. So F-score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. And this is recall comparison graph. In this graph on x-axis I have recall score and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is accuracy comparison graph of different algorithms built using Malgenome dataset. And this is precision comparison graph built using Malgenome dataset. Similarly, these are recall and F-score comparison graphs of different algorithms built using Malgenome dataset. Similarly, we can see performance comparison graphs of different algorithms built using CIC Malware 2020 dataset. So this is the accuracy comparison graph, this is precision comparison graph, this is F-score comparison graph, and this is recall comparison graph. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is dataset folder in which I have 3 different datasets on which we will train our models. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. These are model files which contain algorithm information. These files will be loaded into the project code during runtime. These are notebook.ipynb files. So these are Jupyter Notebook files which contain combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. Now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open the Anaconda prompt. Use the command cd followed by a space and paste the copied path here and hit the enter button. So this command is used to change the current directory to the code folder's path. Now Compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. So after running the app.py file, the Flask framework will host the application locally at the default address, local host and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Now click on this. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on sign up button to register. And if we already have an account, we can directly log in by clicking on the sign in link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password. And click on sign in button. So it has redirected us to the malware detection page, and here we have to provide all these parameters. So first we'll understand these parameters. The first one is read SMS. So it is permission to read SMS messages. Send SMS is permission to send SMS messages. Use credentials is permission to use stored credentials. Read sync settings is permission to read synchronization settings. Read calendar is permission to read calendar events. Write secure settings is permission to modify secure settings. Battery stats is permission to access battery usage statistics. Kill background processes is permission to terminate background processes. Change network state is permission to change network connectivity settings. Transact is function or method call for inter-process communication. Java lang class get canonical name is Java method for obtaining the canonical name of a class. Java_lang.class.get methods is Java method to retrieve an array of method objects reflecting all the methods of the class. Android content context register receiver is Android method for registering a broadcast receiver. GetBinder is a function to obtain a binder object. Create subprocess is a function to create a subprocess or child process. Telephony manager.getDeviceID is an Android method to retrieve the device unique identifier. Class loader is a mechanism for dynamically loading Java classes at runtime. Android Telephony GSM SMS Manager is an Android class for managing GSM SMS operations. OnBind is an Android method for the binding of services. Package Installer is an Android class for installing and managing app packages. Android Telephony SMS Manager is an Android class for managing SMS operations. And Runtime Execution is a Java method for executing system commands. So these features represent various permissions, methods and classes that are analyzed as part of the Android app's static features to identify potential malware characteristics or behaviors. So now we'll fill in all these details. So the read SMS would be 0. Send SMS is 0. Use credentials is 0. Read sync settings is 0. Read calendar is 0. Write secure settings is 0. Battery stats is 0. Kill background processes is 0. Change network state is 0. Transact is 0. Java lang class.get canonical name is 0. Java lang class get methods is 0. Android content context register receiver is 0. Get binder is 0. Create subprocess is 0. Telephony manager.get device ID would be 1. Class loader is 0. Android telephony GSM SMS manager is 0. OnBind is 1. Package installer is 0. Android telephony SMS manager is 0 and runtime execution would be 1. Now click on predict button. So here we can see the result. Malware Android attack is detected. So the malware is detected. Now click on this, click on home link. So now we will give another set of parameters. So I have given all these parameters. Now click on predict button. So here we can see the result, benign Android attack is detected. So it is classified as benign. So similarly we can give any set of parameters and can get the classifications. Now click on this and click on sign out button to sign out. So the conclusion here is, the project demonstrated the effectiveness of machine learning models in detecting Android malware. These models showed strong capabilities in identifying malicious apps, which is crucial for protecting Android users. Ensemble methods proved to be more efficient than individual algorithms. This approach of combining multiple models enhanced the overall detection accuracy, showcasing the power of ensemble learning. The project highlighted the significance of combining both API and permission features. This combination was found to be critical for improving malware detection, emphasizing the importance of considering multiple static features in analysis. The performance of machine learning models varied across different datasets such as Rebin, Malgenome, and CIC Maldroid 2020. This underscores the importance of careful dataset selection and understanding for developing accurate detection models. The models achieved a balance between accuracy and minimizing false positives. This is essential as it ensures that while detecting malware, legitimate apps are not mistakenly flagged as threats, reducing inconvenience for users. And the outcomes of this project have broad implications. Security professionals can use these improved detection techniques to enhance cybersecurity. App developers can better safeguard their apps against potential threats, and end users benefit from increased protection against Android malware, ultimately leading to a safer mobile experience.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.